So this is a video run through of the more rational functions worksheet. So again, I'd advise a good way to use this is to print off the worksheet and work through it, and then watch the video, and then work through the next one and watch the video, and etc., etc. Okay, so again, you start off by factoring, and this would be x minus 2, x plus 2. And here, if we factor out an x first, then we can factor out an x, and a 2 and a 1. And I think that'd make that positive and that negative. So we have roots on the top would be 2 and negative 2. Roots on the bottom would be 0, 1, and negative 2. And notice that I have some matching roots on top and bottom. Those are going to produce a whole. So the domain would be all real numbers except for x not equal to 0, 1, and negative 2. 0, 1, and negative 2. Those are the three places that I'm dividing by 0. Two of those are vertical asymptotes, so x equals 0 and x equals 1 would be asymptotes. So let me draw that in real quick. There would be a hole at negative 2, and we plug negative 2 in back up here, so we're plugging negative 2 into x minus 2 over x times x minus 1. Because remember, you plug it in with the common factor canceled out. So if I plug a negative 2 in here, I'd get negative 4 on top. Plug a negative 2 in here, I would get negative 2 times negative 3, which would be 6. So that's negative, whoops, daisy. That would be negative 2/3. So negative 2/3. So negative 2 and negative 2/3, that'd be right about there. There'll be a hole. Okay, looking good. Notice, oh, and then x-intercepts. Well, first do the y-intercept. Looks like the y-intercept is going to be, oh, there is no y-intercept, right? Because we have an asymptote there. So that'd be none. And x-intercepts, that would just be 2, 0. So that'd be right there. And so intervals above and the x-axis, well, we know that it's below right here because of the hole. So we know it's below from negative infinity to 0 for sure. And so we're assuming it looks something like this. Who knows where it goes from there, but it looks, well, yeah, it's got to stay below the x-axis, so I'm guessing that there's an asymptote there. Let's check in behavior real quick. This looks like the case, the first case where the degree on top is smaller, less than the degree on the bottom. So this would be a horizontal asymptote at y equals 0. So sure enough, there's a horizontal asymptote there. So this thing's coming down and like that. Okay, so then now we also know that because there's a single multiplicity for 0 right here, that because I'm going down here, I have to be going up here. So squeeze a little up in there. And since I don't cross there, it must also be going up here. So I don't know how low it goes, but it must do something like that. We could check that if we wanted to. You could maybe plug in a half to see where it's at, but for our purposes, right now we're just going to go with that. So that tells me that intervals above would be definitely from 0 to 1. Oh yeah, we got to break this up a little bit actually, because that hole there, it actually goes from negative infinity to negative 2, and then from negative 2 to 0, because it's actually not doing anything at that hole. Okay, so now because there's a single multiplicity at x minus 1, and I'm going up on this side, that means I have to be going down on this side. So should be going something like that. And it will shoot straight across because that's a single multiplicity up there. And since we have a horizontal asymptote at y equals 0, this thing must turn around and come back down like that. There we go. Perfect. Moving right along, this one we'd factor first. X and X. It's like 3 and 1. Plus and plus. All over X minus 2. The domain would be all real numbers. X not equal to 2. We got roots on top are -3 and -1. Roots on the bottom are 2. And since there's no matching roots on top and bottom, that means that bottom root is a vertical asymptote, so that'd be x equals 2, which means that I have a dotted line right here. The holes, there isn't any. None. Y-intercept would be 3 over -2, which would be -3/2. So that would be right about there. That's good to know. Hey, stop that. Okay. X-intercepts. Let's see. We got -3 and -1. -3, 0 and -1, 0. So that'd be right there and right. Stop that. -1 and -3. That's good. Okay. And so now intervals above and below. We know that we're below here, and it comes down like that. It's got to. Has no other choice. It can't turn around and go back up because we'd see the crossing. Here it must come up and go back down because these are both single multiplicities. Where it goes from there, we're not sure. Over here, it must be up here because single multiplicity, it's the opposite of that. So let's see. It's below from -infinity up to -3. And it's below from -1 to 2. And that's it. And so therefore it's above from -3 to -1. And it's also above from 2 to infinity. In behavior, we look at this. It's the third case. The degree on top is greater. So we look at the difference in the degrees. It's 1 greater. So this thing behaves like a line, which means it will have an oblique asymptote. Let's move this up. Oblique asymptote. And you can find the oblique asymptote by dividing this. So I'm going to take 2 in the box, and I'm going to run it through synthetic division, because that's how we divide that by x minus 2. So let's see, that'd be 1, 2, 6. 2 times 6 is 12. We don't care about the remainder. So there's an oblique asymptote at y equals x plus 6. So let's go in there and plug that in. 1, 2, 3, 4, 5, 6. Okay, so this thing's a little bit off. It's going like this. So that is going something like this. And this guy's just going to kind of go right in there. Okay. All right, let's do another one here. This would be 5 times x minus 1 on top. And that would be x squared times x minus 2 on the bottom. So the roots on top would be 1. Roots on the bottom would be 0 and 2. And 0 has a multiplicity of 2 because it has 2 factors that produce 0. No matching factors. Let's see, the domain would be all real numbers, x not equal to 0 or 2. We're going to have a vertical asymptote at x equals 0 and at x equals 2. no holes. Y-intercept none, because we have a vertical asymptote there. X-intercepts at 1, 0. Okay, so let's graph a few things. So 1, 0 would be right there. We have an asymptote right there. We have another asymptote at 2 right there. We have an x-intercept. Oh, you already got that? Yep. Okay. Intervals above and below. So now this one's a little bit tricky because we don't know where anything is. We have the one crossing there, but we don't have any above or below. So what we can do is just pick a point. Like, for example, I could pick -1 and plug it in and find out whether at that point I'm above the x-axis or below the x-axis. So if I choose -1 and plug it in there, that would give me, so I'm taking 5 times -1 minus 1 over -1 squared times -1 minus 2. So this is going to be negative on top, and that's going to be negative on the bottom, so this would be a positive overall. So I know I'm up here to begin with, okay? So that means I'm going to be going up like this, right? And then also, now here's this is why I picked this one. Notice that the multiplicity of this asymptote, the root that produces this asymptote has a multiplicity of 2, which means the behavior on either side of the asymptote is the same. So in other words, it behaves like this guy, y equals x 1 over x squared. So it looks like that. Okay, so that means we're also going up here, which means it's going to go down here and cross and keep going like that. Because it's got a cross there, because it has a single multiplicity, which means we're also going to be up on this side, because this asymptote has a single multiplicity. So intervals above the x-axis would be from -infinity to 0, and from 0 to 1, and then from 2 to infinity. And the only place it's below is from 1 to 2. Now, in behavior, we look at this thing and it says the degree on top is less, right? Correct? So that means it's approaching, that's the first case. That means we have a horizontal asymptote at y equals 0. So this thing must come down and go like that. And this thing must come down and go like that. Pretty cool. Okay, I think we have one more here, right? Yep, one more. So once again, we'll factor this baby and we get x, 3, 4, negative, positive, and x minus 2, x plus 2. So the roots are -3 and 4, and 2 and -2. That means the domain is going to be all real numbers, x not equal to 2 or -2. Vertical asymptote, since there's no matching here, my vertical asymptote is going to be x equals 2, x equals -2. No holes, because there's no matching roots. Y-intercept, we just plug in 0 for x, and we get -12 divided by -4 is 3. So that would be 0, 3. X-intercepts are these roots on top. So that would be -3, 0, and 4, 0. And let's put some of the stuff in. So 0, 3 would be right there. -3 would be like 1, 2, 3. Positive 4 would be 1, 2, 3, 4. The asymptotes are here at -2. Positive 2. Okay. Very interesting. Notice it doesn't cross in between the asymptotes, so this must be a kind of a U-shaped thing here. So I'm guessing that it must look something like this. It might be lopsided or whatever, but it'll look something like that. And since both of these roots that are producing asymptotes have a multiplicity of 1, that means it must be doing the other behavior on the other side. So it's got to come looking like this, and it will cross there because those both have single multiplicity. And looks like the end behavior, we got degree on top and bottom are the same, so we look at the ratio of leading coefficients. So there's going to be a horizontal asymptote at y equals 1, because we're looking at just these guys here. So I made that a little bit too high there, got carried away. There we go. So where's the intervals above the x-axis? That would be from -2 to 2. And below would be from -infinity to -2 and 2 to infinity. Oops! Nope, I just lied. What am I thinking there? Also from -infinity to, what is that? -3. And then, yes, and then from, let's see, 2, 3, 4, from 4 on. And the interval below is from -3 to -2. And over here would be from 2 to 4. That was a close one. Okay. So, there's the worksheets. Hopefully you're getting the hang of this stuff now, and please send me an email if you still have some questions or struggling about, or yeah, if you had some questions about something you saw in here, please send me an email.